it's live, but yeah, okay. So, welcome.
Good afternoon.
Today we will discuss first. First we will announce now the winner of the last battle. I know that you want to know who won. And suspense.
I think Taxi's got it. So yeah, congratulations
So
to
for
Taxi.
us, Taxi.
We really thank you folks. I mean, both presentations were really good. Both teams were really committed. But we think you nailed it by largely by two factors. First, by the fact that you were in some way, you had some significant flaws that in some way you were able to dodge from the perspectives of the other folks. So we were expecting the other folks to attack you very strongly on the fact that you were kind of outdated, you represented an old solution, and either they didn't drop the, take this argument, or you were able to dodge it very effectively. So in some way you were able to harness this better. And this, I think, was what really nailed it. I mean, at least in our opinion. But the other group was also very interesting. I think the presence in the discussion was very good from both sides, but ultimately what kind of tilted the scale was this factor.
Also, both the initial presentation were really good. Presented really well the point of view and the strength of the two views. Both the team presented well their own view, also during the discuss. But at the end, one team didn't get to attack the other in an efficient way, let's say, while the other team, the Taxi one, was better in defending themselves.
So what we should do now after the battle? We prepare a report.
So, of course, you're free to start working on the report.
Yeah,
You might want to have a template first, I guess.
Yeah.
If you want the template, you will need to wait a bit more because we're a bit overloaded at the minute.
Okay.
But we will have it as soon as possible.
Yeah, basically
Because
the template would be Taxi Vision, Uber
Yeah.
Vision.
But for the report, we should have a group report.
Yes.
This is a joint, so to remind you of the rules of how the report works.
Because
The report for the battle is joint between the two groups, okay? So you've probably had a team of 4 or 5 people defending one position and 4 or 5 defending the other. Those two groups work together into writing the same report, okay? I think this was, we already established this, but this is how it works. So you team up with the two groups and you deliver jointly a report, okay? The rough template is introduction of the topic at stake, scenario, vision 1, vision 2, conciliation, conclusions. Nothing too fancy, I mean, it's very logical. But we will give you an example of a report and more detailed structure in the coming weeks. I won't commit to a date. Delivery is by Christmas, so you have time.
Yeah, and it's 10 pages.
Yeah, we expect roughly 10 pages. I mean, if it is 12, we're not killing you. If it is 20, we might. But yeah.
So it's 1 page for each person. More or less, right. Okay, so today we will discuss and we will present you, and we will want to also discuss with you the environment. Now, what we mean when we talk about environment, because maybe you can think that environment is the tree, the animals, or all the other stuff that is related to the natural environment. Is also this side, this part, but it's something more. When we talk about the environment, we saw in the last week we saw when.
Sorry, just one point. As usual, please, I ask you to close your laptops because now we give you a broad overview, but then we'll ask you to also come into the discussion. So please, if you can shut down your computers, that would be really appreciated. Okay.
Maybe later you will use it.
I don't want to be policing and traveling and telling people, will you please shut down your computer? Thank you. Would you please shut down your computer? Thank you. But I think you're mature enough. Okay.
Still, we saw last week when we discussed about the organization the relation between the organization and the outside world of the organization. Today we will nail it better, so we will discuss more in depth the how we, as innovators, as entrepreneurs also, but before from a more theoretical point of view, how we can perceive the world outside and how we can create it in some way. Then we will discuss it. So first of all,
So this, as in the approach, this is really a step back from what we did before. Okay, so we are taking some time to detach ourselves from the concrete reality, from how you do things, from how you actually implement them, and we're going a bit more philosophical on this. Okay, I know that some of you will have the question of what do we bring home from this lecture, which is a fair question, and I think that if the question is still open, we will have an explicit answer at the end of the lecture. Okay. And we will deliver on this, okay? But the point is, let's take some time to detach from the object level, from the concrete reality, and let's start thinking about broad questions about how we view, how we work, what our approach to science is, and what is an innovation, and how do we carry all of these reflections on, okay?
yeah, exactly. So this is the point of today to start. So trying to be more philosophical at the beginning, then we will have some more concrete and practice example also. But the first question that maybe we can discuss and we can try to understand is basically what's the world that surrounds us, that is out, that is in here, that is out of you. Is it really there? How we can perceive it? How we know? What is the knowledge? How we can create the knowledge to know the world, basically. So this is the more philosophical question that we can discuss it as, let's say, in what is called an epistemology point of view, using the word from the philosophers. But we'll try. I don't know. Maybe how many of you studied philosophy in high school or something like that? So maybe you know about epistemology, maybe discuss also in some course here, probably about ontology. So
just to see, just to have some quick survey.
Yeah.
Does anybody here know the word epistemology? Just the word epistemology. Okay, there's 3 or 4. That's significantly less about the people that said that they studied philosophy in high school, by the way, so this is quite worrying. Does anybody of those people want to help me understand it, etymologically, how this works, or at least in broad strokes, what epistemology is? Epistemology. Don't Google it up, please. That's
Yes, I know it because I don't know it in English.
okay, good. No, but we will construct the definitions here anyway. Anybody here wants to has some reminiscences, please?
Just like the meaning of the word where comes the idea and then
Yeah.
So when one says epistemology is the studies of the meaning of the word, why the word got to have that meaning?
No. You're maybe confusing it with etymology.
Yeah.
Etymology is the study behind the meaning and the origin of the word.
You say
Epistemology. So let me just.
Epistemology.
Okay, this is the word. Yes,
I'm
please.
not sure, but I think it's like the philosophy of knowledge.
Exactly. It is the philosophy of knowledge. Episteme is in ancient Greek the knowledge. So in some way this represents the philosophy of knowledge. This means how we get to understand things, how we get to perceive, process them, make them our knowledge. We're not going as far as defining what knowledge is, because this might take, a while, let's say. But for now, let's take it as epistemology is that branch of philosophy which studies how science acquires knowledge and how we process knowledge in broad strokes. Okay? So this is the framework for today. The framework from today is knowledge. How do we process it? How do we, in some way, acquire information from the outside and transform it into something useful?
How do we create it?
Yeah.
Yes, basically. So the first question, as I said, this one. So how do we come to know? And epistemology will guide us in this lesson to understand it. Also, what is the truth? If something is really there or not, if something is not the truth that we want, how we can change it, how we can build a world that match our views, for example, and how we can, with our action, with our words, with our being present, be innovators, how we can create something new that wasn't there before. Okay, so this is what we want to discuss with you today. I think we can start.
So let's the approach we take here is the following. We give you a quick primer, and we want this to be like quick and dirty. You try to help us in constructing this and like making sense of it. About 4 key words that will define our framework for the rest of the lecture and the rest of the course. This is just to establish a common vocabulary, okay, and have some first level of examples. Then we take some time, we pause, and we take plenty of time to exemplify and to study a bit deeper the meaning of this, okay? So for now, we take 4 categories. We give you a word, we give you a meaning, and we give you a first level example. Then we take some time to go deeper into this. So if you are confused, try to channel your confusion into the second part when we can actually come up with examples, okay? So keep your confusion there because that's precious.
So let's play a game. The roulette. Do you know the roulette? But with some differences with the real one. Let's take that we have a roulette where all the numbers and the colors are replaced by the same numbers and colors. So we have a roulette with only the number 7 and the red color. What happened?
So you can ask yourself like this: if we have a roulette in which all the numbers are the same and all the colors are the same, what is the probability of getting a red? It's 1. What is the probability of getting a black? 0. This is quite trivial, right? This shows us a very simple and straightforward type of environment, which we call it, pressing the wrong button, certainty. Okay, so first broad category for today is certainty. We are in a world in which things are either like undeniably true or undeniably false. There's no way we can alter it. That roulette is always going to make up a red 7. If you bet on a black number coming out, that's not very smart. There is no space for decision in some way. There is no space for making elaborate conclusions. The knowledge we have is what we observe immediately, and that's it. Okay? No space, but that space.
Now, what if we have the classic roulette? So 37 numbers, 2 colors, actually 36 numbers plus the 0 and the green. But how do you play to the roulette? How do you bet? How is the word of the classic roulette?
Uncertain.
Well, okay, let's keep it there because we'll need this.
Yeah.
As in, it is uncertain. As in, it is not certain, right?
It's less certain than the previous one. This for sure.
But we know which are the possible outcomes.
Exactly.
All
So
the
let's say you want to bet on the red color coming out. What is the probability of getting red? This is basic probabilities, folks. If you don't get this, that's okay. Back to high school. What is P of red?
I don't know how are you.
So there's 37 numbers.
Yeah.
The black is neutral, so it doesn't count neither as red or as black. Okay, so roulette works like this. It's a wheel with numbers
Yeah.
0 to 36. Okay? each person can bet on a range of numbers, so they can say, I can bet that I will get something between 1 and 5, 1 and 8, 1 and whatever. And they are either black or red, okay? You can bet on the color, you can bet on the single number, or you can bet on a range of numbers. And you get paid proportionally. If 0 comes out, 0 is a loss for everybody. So whatever you bet, if 0 comes up, the house, which is the person running the game, gets all the money, okay? So the probability of getting red is 36 divided by 2 is 18. Yeah, 18. Okay, makes sense. So that is 18 over 37, right? So, and this, can we alter this? Can we make it so that the probability of red becomes 20?
We have to change the game.
We would have to change the game, right? We would have to like alter the roulette, change the colors. This is not something we can do yet.
Yeah. So this is a risk situation. Risk, we mean that probabilities are lower than 1. So I mean, in the case of red, 18 on 37. But they're given and known by everyone. So every person approaching the roulette know the probabilities of the to bet, for betting, to choose how to bet. So the knowledge that we have is true because the probability are true, are there, are known by everyone. But it's true with a given probability. I mean, if I want to bet to the number 7, I know that I have one probability on 30 on 38 to 37 to get it. So the knowledge is a collection of data that we acquire with a given probability. So we, in this sense, to each number or to each possibility, we have a probability fixed that this case will happen. So this is a risk situation.
Do you see a winning strategy in this situation? So can you imagine some different strategies to approach this problem of the roulette? So say you want to step into a casino and you want to win at the roulette. Can you do this? No? Why?
Because the expected value.
Mm-hmm.
At the end, the casino, if I play many times, at the end the casino wins.
Yeah, because there
That's
is
the business model.
because the game is rigged in some way, right? So they're cheats, and they put the 0, which means that on average, still you're going to lose by probability, which means that since this is 18 over 37 and it's not 18.5 over 37, this means that if we run enough games by the central limit theorem, eventually this thing will become at a loss for the player, okay? But if you look up, I think if you even look up roulette on Wikipedia or something, you will find that there are some strategies which actually like try to minimize your losses and therefore put yourself in the situation that since you don't play enough times, you might win and come home with something to cash in your pockets, okay? So there are some strategies in Risk which allows us to minimize the loss and in some way allow us to bail out without loss, if we're lucky. If we're not lucky, we lost. Okay, that happens. It was a risk. It was a known in advance risk. Everything we already know, and it has a set probability. Probability of red is 18 over 37. The probability of 1 or 7 coming up is like 1 over 37. The probability of numbers 1 to 5 is 5 over 37, and so on. Everything is known before. So I can challenge you to a game of roulette, and we can choose different betting strategies. Some of us might win more than the other. In the end, we'll eventually like all lose with respect to the money we've committed. But different strategies can lead to different outcomes. But they're all set in stone. The probability is given from before.
Let's change again the game. So in this case, at the beginning, the croupier as a different kind of roulette where you can see the number, you can see the color, and you don't know which number and color are in the roulette. And you can know the number only when the ball stops and the croupier show you the number. So basically, you don't know nothing. You go to the table of the roulette at the beginning, and in the roulette could be number from 1 to infinite, but you don't know which number are there, and you don't know which color are there.
The distribution is different, which means that, for the sake of simplification, we might take still a number from 0 to 36, but there might be duplicates.
Yeah.
Okay?
Or
So there might be 7 fourths.
Also.
Okay? But you don't know it in the beginning. You go there, and the roulette has a bunch of blanks. Everything is covered with a small piece of cloth, or whatever you want to imagine, and you don't know what is underneath each number until the ball lands there, and the croupier takes away the piece of cloth and shows you, this is a red 4. Now you know that there is a red 4. And that is going to be staying there for the rest of the game. Okay?
How can you bet?
It's a blind bet.
Sorry?
It's a blind bet.
Blind bet.
The beginning is a blind bet, but let's assume we take like 10 games, okay? And it comes up that we get 5 red numbers and 5 black numbers. Now, the bet is still blind, as in we don't know the full picture, but we know that we have 5 and 5. Let's say that we play 20 games and we only get red numbers. Now, if you bet on the red, you know that you are more likely to win than not, because now there's more red numbers than on average, than the total, roulette. So in some way, this evolves over time as we play it, right? By contrast, if you don't see any 0 or any 7, you might assume that there is, there's none. So this might give you the chance, the hint that you are not betting on that number. Yeah.
So this is the uncertainty that someone mentioned before. So it's a case, is a war where the probabilities are not known, and the probability vary according to our capacity to acquire and process the data that we collect. So the data are in the roulette, while when the croupier show you the number, you can know, you have the data, you have the information then to process and to understand how the roulette is composed. But you need time to acquire, because you need to play 20 times, and to play 20 times, so you need time, and also you need resources, so you need money to bet and to lose at the beginning, probably.
I mean, the thing is that if you take the same scenario, assume you have a very small pool of money, like, I don't know, you have 5 chips, and you must at least bet 1 chip every time. If you bet unwisely, according to what is actually happening there, which you do not know, or to your own mental model, you might find yourself running out of resources. Now you have enough information, but you have no resources to bet. Or the game might end after a certain set number of rounds. You might have unlimited resources, but you might lose whatever you put there because you haven't acquired enough information to make an informed decision, say, or a decision which turns into your advantage. So at first, you are effectively spending your resources just to explore the realm of possibility, acquire information, and in some way find a lower and an upper boundary to what the true value of the scenario might be. Because in the moment in which you roll, the ball goes, a red number comes out, now you know that there is at least 1 red number. That gives you a lower boundary. In the moment in which, a second red number shows up, now you can update this. There's at least 2. And you can iterate and you can proceed over this to get a better refinement of this every time. Of course, this game which we're exemplifying is a boundary, but if you think about it, and as you are proceeding and as you time to do this later, you will see that there are plenty of examples in which this case happens. Exactly
So,
in this way. The key point of information here is the following. The roulette in which we're playing is set from the beginning. There is no cheating going on. The distribution is unknown to you, but it is set. This means that if we play enough games, eventually all 37 tiles will be revealed and everybody will have perfect knowledge. Okay? Of course, what is the probability of getting all 37? How many games do we need to see all 37 cells? What?
We don't know.
Trick question. No. We have no idea, of course. That's not, no. The point is exactly the following. I made this trick question, but it's serious. The thing is, even if we have a limited space, we do not know how many games we'll need to have a perfect knowledge. This means that if we haven't seen a 0, and there is all but one tile are not shown yet, the 0 might be there. We might still be in a disadvantageous situation in which the house wins. We might not know it. This is uncertainty. We can improve and refine. Often, the feasibility of getting a perfect refinement on the information is not achievable. So we cannot degenerate uncertainty into risk.
We will discuss
We'll
later.
have time for this later.
Now, let's change again. So, same rule as before, but with the difference that every time that the croupier shows the ball, the roulette is randomized again. And a new distribution of numbers and colors will happen.
So this is the case in which effectively, we say that the distribution of red versus black and the distribution of numbers is random, according to some distribution which is in the mind of the croupier. Okay? We play a game. The croupier takes away this piece of cloth over the number and it says, wow, a red 4 came up. You say good, you might have won, you might have lost. Then the croupier puts the cloth back in. He re-randomizes the entire roulette so the distribution changes again. You don't know how, and then you play again. Is there a winning betting strategy in this case?
No.
Quite clearly there isn't. If you are forced to play this game, how can you avoid losing too much? What?
Don't play.
Yeah, you don't play. I mean, that's a good thing. The reality, the sad truth, however, is this. This game, for as silly as it sounds, is one game which we play almost every day in a lot of situations of our lives. We are forced to play unless we run underneath a train, I guess. But the point is, there is one possible winning strategy. There are a number of possible winning strategies. Can you see them? Can you?
The obvious one, I keep betting the double. I keep doubling the amount that I bet and assuming that I have an infinite supply, I can go on until I win. This is a nice one. This is called the escalation of commitments in some way, in some literature which we might explore in the future if we have the time. You pick one strategy and you single-mindedly commit to it, doubling every time your bet. Okay? If you have infinite resources, eventually your bet will come true, and at that point, since you have kept doubling and doubling and doubling, you will win more than you bet initially, than all you have bet. So you will recover all your investment and you will win. This is one opportunity. Other ideas?
That still works also for the other ones.
Also for the other ones, that works.
This strategy.
The 0 is what kills the strategy in the roulette, by the way.
Yeah.
Other ideas? Of course, here we have to make assumptions, right? He said, assuming that I have unlimited resources, then I can do this. So feel free to propose an assumption and propose what your strategy would be.
For the one that changes very randomly, it just came to my mind that what if we always bet on the same position of the ball?
Mm-hmm.
Because if it's going to change randomly, and if we, I don't know if it's logical or not, it's just an assumption. If we change our number as well, then there may not be any conflicts. But if we choose the same number again and again, then the distribution may come to the point that our number is the same as the one.
So you're saying if we pick not the same the number but the same cell, right?
Yes.
So I'm saying I'm putting like a cross on one piece of cloth and I will keep betting on that cell until eventually it comes up.
Yeah.
And then I will see what is underneath it at some point, hopefully, right?
Yeah.
what do you get from this?
I get that if I change the number and if the distribution being changed, since I cannot predict the distribution, changing the number is more riskier than staying on the same number.
Okay, so your idea is in some way, I have too much variability. I keep fixed one variable, so at least the complexity of the variability in some way is reduced.
Yeah,
right?
Yeah, exactly.
This is interesting. It doesn't have a practical turnover to it because, of course, if what happens is effectively randomized every time, and this is exactly the way Andrea describes it is exactly the way the game is run. This is not a winning strategy, but it is one which in some way says, well, in all of this complexity, I have one certainty. I insert an element of certainty.
Yeah, you actually reduced the
space possibility.
The space possibility, yeah.
Okay, that's interesting. Please.
I guess with more numbers.
What, sorry?
I don't pick up a number only, but
Mhm.
I pick 2, 3, 4, 5.
I spread my investment across a bigger space of possibility so that in some way I expect that at least one is going to pay off,
Yeah.
hopefully. Maybe my return on investment is going to be small, but I'm getting something. Okay, this is definitely a possibility.
This could be done also with the normal roulette.
This also works for the normal roulette, by the way. Your idea is good. I mean, of course, you might be in the degenerate situations which you bet everything from 1 to 36, let's say, and then it turns out that there is just zeros. But this is like unlucky. You cannot foresee it. Other ideas?
You can assume that the roulette is like the standard one, and just play to the standard one. Since we have nothing better to grab on, we can maybe see if playing different games. We start with the idea that is the standard one, and going on, looking at the different games that we play, we may adjust this model. Since if for some reason the zero is biased and there are 3 zeros, and we see that it comes up very often, we can change our mental model to the zero is more probable than the normal roulette.
You can say, so his idea in some way can be condensed like this. You say, aha, I know my roulette. This is how a normal roulette works. And the croupier is telling me that he randomizes every time, but he might not do it, for example. I have no idea. I do not know. So I can start using the same strategy as I would use for a normal roulette. And if I see that this strategy has a falsification, then I update my mental model accordingly. This is also a strategy. There is one which is still missing, which...
Is the distribution used to randomize the number fixed? I mean, it's always the same or...
No.
You do not know.
You don't know. You don't know this.
It might be or it might not. You do not know.
The type of distribution that the croupier is using.
You do not know. Or I could say it's like some esoteric distribution which confuses everybody. So no, you do not know. For now, we can make this assumption. There is one. Well, I'm putting this on the table here. One last strategy which has not came up is that of risk aversion. It's saying if I have to play, and assuming I have a limited number of resources, I try to place the smallest possible bets so that I can acquire the most information possible, or I can drag on the thing for as long as possible. Because if we're playing this roulette and eventually when I'm running out of resources, somebody shoots on my head or whatever, I can try to drag this on as much as possible by being risk averse, by putting small bets, either because I pick a very big range of numbers or because I just bet small quantities every time. I'm trying to drag this on as much as possible.
So this is what we call the ambiguity one, or weak ambiguity. So the word is ambiguous. We don't know how it works. Data are meaningless, external. I mean, you can acquire the number, but you don't know how the distribution is. So it will change in the next game. So you can say have an information about the data. The information in this case is the meaning given to the data by the knower. So you create the model, as you said before. So basically, you try to create a model to understand what is there, but you don't know if it's the truth of what is there. So you create your own model. You try to interpret your information using a frame that you create. And in this case, the knowledge that you create is your frame. So is how you understand the data out there, the world out there that you don't know. But you create inside yourself a model, a frame, to read it. Yeah, and you think it's true, but you don't know. You need to believe it. It's true, let's say. So you need to stick it and play as it was a normal roulette, or you need to continue betting the small amount of money, or you need to continue to extend the number that you bet on, or whatever, and believe that is the truth.
So in some way if before we were in a situation in which we had an external objective truth of what the roulette was, now this is changing. It is true, but we do not know it. There's no way we can know it because every time it's randomized. The croupier might not even know it himself because he might, press a button and the numbers get randomized by himself. So nobody has an understanding of what is there, and an objective understanding of what is there, and each of us will have their own subjective understanding of what is happening. His mental model, which he proposed, was, well, I'm basically expecting to have a normal roulette in front of me, is different from her mental model and is different from the mental model which has been proposed by lots of different people here. And each of them is in some way put into place in this common space, and each of them is going to act according to their own knowledge and according to their own framework in which they perceive this. There is no right or wrong. Everybody has their own mindset. Everybody tries to subjectively make sense of it, but how this pans out and how this evolves in practice is unobtainable.
Then, same rule as before, but players can spend resources to change the tides and make odds in their favor. But nobody will try to do it, and each player has this potential. So you can convince the croupier to change the number when the balls stop and win.
So this effectively,
cheating.
yeah, that's cheating. That's cheating, right? It is
Yeah.
in a normal game. This
in
is
this
cheating,
game is not a cheat.
but
Yeah, the cheating also in the real world, however.
Really?
this is a type of cheating which this game which we're building relies on. Okay, so we are saying in this case, this is part of the game. Every time we play this roulette, okay, and it is a normal roulette as we all know it. Okay, we start from a normal one, then we say, okay, each player comes with a croupier and they say, okay, I give you 10 chips and you put 3 fours. And he says, all right, I'll take your offer. And he records it.
Yeah, the resources could be the chip, but also that you are more convincing than the other player.
So he can take money from both of them and then decide to not don't do it.
Of course, this might very well happen that he takes offers from everybody and then he decides to do nothing.
But you don't know it.
Look, the croupier here is a proxy of what? Sorry.
He's the only one that is earning something.
Yeah, he's the only one that's coming out with something in his pocket. That's for sure. He was also in the fair roulette, by the way, because that's how he gets his salary, incidentally. But the croupier here is a proxy. So, let's take a step back. Taking this scenario, what is in this scenario? There is a roulette, which is an object, which is not a person, which does not have any decisional power, and does not perform any actions actively. There are players, which are assumed equal in some way, maybe in this case except for a number of resources, but we can assume them equal, and they all have an equal footing and an equal opportunity, let's say. And there is the croupier. The croupier is in some way the one that runs the game, and he is a proxy for the environment itself. He is a proxy for what you are trying to alter. You are trying to alter the roulette by acting on the croupier. Your action might not lead to the consequence you're thinking, because as much as we will discuss later in other examples, there are some ways in which you are negotiating with somebody and you're trying to get him to do what you want him to do, but he doesn't. And there's no way you can like kill him or nothing. There's no violence admitted, okay? But this means that the croupier, who is a proxy for you to act on the environment, which is the roulette, which we are sharing, might ignore your actions. This is perfectly legitimate, okay? So each player has the same capability to alter the environment, but what will actually happen is unknown to us. It will happen through the interaction between the players. It will happen through the interaction with the croupier, right? As a player, I might go to him and say, you know what, I don't offer anything to the croupier. Let me handle this, okay? I'll make my and your best interest. What are you betting on? You're betting on red. Great, I'll bet on red myself. I go to the croupier, I spend my resources, and we both come home with a red, okay? The discussion and the interaction between the players themselves and with the croupier tries to alter the common environment, which is the roulette. It might not, but it tries to.
So what are you saying is that players can collaborate to change the environment?
Nothing stops them from doing so.
But they're also not collaborate and be just enemies and say, okay, see the other player as someone that wants to steal the money of the other. So this is what we call the strong ambiguity, or ambiguity 2. This is just a definition, so to have this ground vocabulary also for the future. And in this case, the word is not specified, but we can manipulate it. So different words are possible because, I mean, you can change a different time and different people can try to change it. So our action actually manipulate the words, and we want to create a word that match our vision. So we want to create a word, for example, that when the roulette works with a winning odds for us. Let's say that we want to bet on the red, we want a roulette with all red number. Without the other, no, obviously, because otherwise all the people will bet on the red number. There are many players to the roulette table, so there are many different conflicting words possible. And the challenge is to convince the others to comply with your own view. So convince the other players and the croupier that your world view is the better and the better for everyone. But when you change it, when you create the new word, the new roulette, this will constrain both the other players, but also you. If you achieve to have a roulette on with the red numbers, you will always lose if you bet on the black, for example. It is there if you can do it. So you will be constrained by your own word, basically. Okay. This is the most extreme situation. So we went from certainty to extreme ambiguous word.
So the way we built it right now, we built it kind of, well, top down or bottom up, the way you can imagine it, right? But we can also build it the other way around, right? We can start from ambiguity and say, well, I mean, we are in a totally ambiguous situation. Put some constraints, and we get to a weakly ambiguous situation. We put some constraints, we get to uncertainty. Put some constraints, and so on until we collapse into certainty, right? So the goal of this first time here was to give you a primer on the lexicon which we're using, okay? The vocabulary which we are adopting for this reflection. Now, we want to take some time to have your examples on these 4/5 categories, and we try to discuss them together, we try to frame them together, we try to make sense of them and how they fit into these 4/5 big categories. Okay. So any examples you have, just raise your hand. You say, well, I have an example of risk, which is the following. I have an example of certainty, which is the following. Okay.
The real world.
The real world. It might be you can look from now. Then from now to the end of the lecture, we take examples without discrimination. Real world, movies, games, shows, anything is fair game. Okay.
Isn't there another category? I mean, let's say I found my startup and I know that I will either success or fail. I know the outcomes, but I don't know the probabilities, and this doesn't fit perfectly, neither in risk, neither in uncertainty.
Well, I give you one more step. You're saying, I found a startup. You say the probability of succeeding or failing is not very known. It is, it can in some way alter. Also, because if you're building jet engines, and then I start building better jet engines, and you don't know about this, what is your probability? It changed. It became lower, right?
Yeah.
Because you started by saying, okay, my probability of like building a jet engine, shipping it to the market, and selling it is 30%. So I don't know, whatever this means. I'm likely to succeed in 60% of the market. Take 60% of the market share. You perceive it as a risk situation until you find out that you have a competitor.
Yeah, but we do not have prior knowledge of. I mean, we can estimate it, but we have no assurance on the precision. So, in a certain way, it's uncertain because even our estimation might be completely wrong.
Exactly. So you're starting from a position which is uncertain. You say, I make an estimation, it might be wrong. But there is another point. The other point is that what if another person is making the exact same assumption, the exact same investigation, and they are investing resources to alter your probability and your estimation. So what I'm trying to say is that what you are modeling as a problem of uncertainty, in my opinion, it's actually a problem of strong ambiguity. Because you are saying, I'm making an estimation, I'm saying, well, this is roughly how likely I am to succeed, but you cannot reasonably have a full picture. Of course, this is still uncertainty, but all the other actors might alter the environment themselves. They might be better than you, and you don't know it.
Yeah, but the thing is that if I do not know something, I'm best off ignoring it.
Are you?
In a probability, in the full probabilistic case.
In the fully probabilistic case, that is correct. But we here are not in a fully probabilistic case.
Yes, but my question was, how do I put this example in?
This, I would put it in strong ambiguity. Because I would say, unless you start making so many assumptions, and start making so many constraints onto this, to make it fit into a certain category, so you say, assuming that all the companies are the same, that they will develop with the same foreseen rate and everything, then you might transform it into uncertainty or risk. But in a real world scenario, your example would be strong ambiguity.
Yeah.
So it wouldn't be some way here. It would be like all the way down here.
Yeah, I agree on that, but that was just an example.
Mm-hmm. Sure. Yeah, okay.
Of something that has determined outcomes, but no fixed prior probability.
Well, my argument is it doesn't even have determined outcomes.
Yeah.
So it's even stronger than what you said.
But still, if we take this example as possible, let's say that we can put all the constraints that we want, and we have infinite time, infinite resource to understand. Then we can go from uncertainty to risk. So maybe you start with an uncertain situation from your side, so you perceive it as something that is as uncertainty. You estimate some probabilities and some distribution of probabilities, and with enough time and enough resources, you can arrive to a risk situation where you know all the probability of all the events. So this is what you can do, in theory.
practices might.
In practice, yes, you need infinite resource or infinite time.
I just want to put one question on the
Yeah,
table
exactly.
to broaden the scope. I don't know if it's the same way we were thinking. So we are all here in computer science in one way or another, right?
The same one.
It was the same one. Yeah, we were discussing about this. How do you think computer science as a discipline views the environment of the problem it is trying to solve? Let me elaborate on this. As a computer scientist, you're faced with a problem, okay? How do you see it? Do you see it as a problem of certainty, as a problem of risk, as one of uncertainty, or as one of ambiguity?
Isn't it related to the kind of application we're talking about?
Okay, then give me an example application.
If you think about data mining, machine learning, stuff like that, we are basically trying to fit a model, probabilistic model, to some input data in order to make predictions. So we are, I think, in a weak ambiguity or uncertainty kind of level. If you are thinking about model checking, probably we are about certainty.
Well, let's give it like this. I'm picking one problem just because it resonates with me and it's with my personal interest. Let's take neural networks. Okay. So does anybody here not know what a neural network is? Okay, it's more than fine. Okay. A neural network is basically the idea that we can model some artificial or virtual neurons, which we call perceptrons, which are basically a function which takes a bunch of inputs, adds them together, multiplies them by some internal value, and if this value exceeds a threshold, then it gives us as output 1, otherwise it gives us out 0. Okay? This is one neuron. Okay? This is how our brain neurons also supposedly work. Most of the machine learning of today works on the idea that we can build these neural networks which can learn situations and they can predict or they can make regressions about all sorts of different applications, okay? So let's say I want to build a neural network that performs an arbitrary task. Give me a task. Somebody give me a task.
Image recognition.
Image recognition. So it tells me, I give it an image and it tells me what it is, okay? Do you think this, as a computer scientist, do you think of this problem as a problem of certainty, risk, uncertainty, or ambiguity? Certainty? Why?
Oh, I know the image.
Mm-hmm. You know the image, therefore either it is that or it is not that. This is what you're saying. Okay, that's what possibility. We had another one? Certainty? Same idea?
But we don't know if the neural network is able to recognize the object.
That's a good point. We don't know if the neural network is trained to recognize the object, right? It might not be. So where would you frame it?
We need the parameters of the neural network.
Yeah, but I mean, in this framework, where would you frame it?
It depends on the knowledge of the neural network, our knowledge on the neural network, so we can fall between risks and uncertainty.
Okay, you would say somewhere between risk and uncertainty because we do not know if the neural network is trained for that. We might need to investigate more. So it is probably somewhere there.
To me, it's uncertain because maybe we will feed, I don't know, a million images and every image is recognized correctly, but we might not have found the flows of the neural network, and maybe the next image will be recognized in the wrong way, or maybe sticking to the example, there are some images that are recognized and adding some random noise that they are not anymore recognizable.
So you are saying this is a problem of uncertainty because I'm feeding the neural network some example, a number of example, and if the number of example gets to infinite in some way, assuming that we can keep feeding it information and it keeps learning, and this neural network, by the way, will need to get bigger, right?
No, my construction in my head, it was there is this neural network that is already trained.
It's given,
and
okay.
the parameters won't change.
Okay.
But we don't know how good it is. And
Okay.
we want to evaluate how good of a model it is.
Okay.
So the function, it's always the same, but we have an infinite, an infinite space of training example that we need to verify, and we can just kind of approximate the goodness of this model, but we won't be sure unless we try infinite.
So you're saying if this is a given, and I want to evaluate how good it is of the
Yeah.
model, I can keep repeating the experiment. I will get always a better estimate of how good it is at
but
doing
I
this
want,
specific
I
task.
want know for the infinity of example that I didn't try, I don't know what will be the outcome.
Okay, there's a very doubtful face there. I'm sorry, I'm just noticing people. So do you have anything to add?
What you do on the test set, you try to evaluate how your neural network is going to perform, but you can not try any program on all possible inputs.
Yeah, that's what I'm saying.
Yeah. So exactly. The point is this. The point is you are framing this as a problem of uncertainty.
Yeah.
You are saying I can keep trying, I can keep refining, I can keep getting a better estimate of how good it is at doing this task, or if I'm at the construction level, I can keep refining it, making it bigger, making it better at a certain task by training on a fixed set. So there's two possibilities. Either I have a fixed training set and I'm refining the model to make it more accurate on that training set, or I have a fixed model and I'm taking a different training set and see how good it is at evaluating.
It's like it's like taking the roulette example, taking the model of uncertainty and having infinite amount of tiles.
Yeah. Okay.
You can refine.
Okay. So this is effectively we are uncertainty. This
Yeah.
is a view of uncertainty. Okay. So we have seen one perspective for which it is certainty, one perspective for which it is risk, one perspective for which it is uncertainty. Anybody that thinks this isn't a problem of ambiguity?
The main assumption of every machine learning task is that the model is fixed. Otherwise, we can do nothing.
Okay. Well, that's fair enough. So you're saying, given that as machine learning we say the model is fixed, this is a problem of uncertainty.
If it is not, we have no need to learn anything.
Okay. Yeah. Makes sense. I mean, I'm not saying whether I'm not testing you on machine learning also because I hate machine learning, but I'm just discussing the philosophical framework behind the discipline. Okay. Okay. So there is some sort of consensus that this is an uncertainty problem. We can argue about that, and indeed I'll bring you an argument later about this.
But what if I have an infinite training set? I can train my model on an infinite training set.
Okay.
I can turn it to a reasonable risk situation.
You are saying if I have an infinitely large training set and I can train my model infinitely, eventually, hypothetically, this would converge to a risk problem.
Yeah.
It wouldn't even be uncertainty, it would just be risk. Either it classifies correctly or not with a set probability. That's also a good observation. Okay, this was just one thing which we wanted to discuss. Does anybody else have other examples on this? Or either on computer science or their own experience or whatever?
About these four.
What, sorry?
About these four.
About these 4/5 categories.
About ambiguity strong one. It came to my mind about administrative corruptions.
Mm-hmm.
It is very common now. It's the very same. You will buy an administrator. He would mostly accept if the amount is satisfying, but he has the option not to take in consider your.
So a bribe is effectively a way to address strong ambiguity, as in you are trying to bribe somebody by offering him money to coerce him into doing what you want.
To change the atmosphere or the environment so that it would lead to my success.
But he might go away with money.
Yeah. And you cannot actually go to the judge and say, I bribed him.
Of course.
If you
This,
bribe the
sir?
judge,
Yeah.
Usually you can't go this. No, that's definitely fair enough. That's definitely fair enough. Bribing or any sort of negotiation in some way is a form of strong ambiguity.
Yeah.
You are trying to alter the equilibrium. The other might say,
Yeah.
I don't care. Other ideas?
If we take our battles, I also think they go to the strong.
Sorry?
The
If
battles.
we take our battles,
Yeah.
they also go there because like it all depends on how the group will do their battle. Maybe they also can bribe people or convince them or something like this.
The battles, the observation made here is that the battles we do in the class are a question of strong ambiguity. Indeed, they are. They are by design. Actually, one of the tasks for next time we will give you later is to read the paper which gives the methodology foundations of the battles. You will see that they indeed are designed to be ambiguous. You can alter the environment, you can try to like bring people to your side. Actually, one year we had somebody showing up with a huge bag of candies to try to bribe the class into voting them, because we were voting with the class. Did that work? I think it didn't, but they tried. They tried, right? They brought huge bags of candies and they said, you vote for us, because we give you the candies. All is fair in strong ambiguity. I mean, in love, war, and strong ambiguity, I guess. But other ideas?
Crossing the street without using the lane is risky. Can we go for that simple things?
Yeah, of course. It's fair enough.
You either die or survive.
Yeah.
Crossing the street, if on a red light, is a problem of risk. The car runs. A car runs every minute. You traverse the street for 5 seconds. The probability of having a collision with a car is 5/60. Okay, that's fair enough. You might get a collision and you might die. I mean, that is a proxy of risk, right? What about, I don't know, a game of Risico, in which I attack you in a game of
My
Risico?
friend here
Yeah.
suggested that our canteen here is the strong
Is a problem of diplomacy, right? The canteen.
The
Also, the
situation
vending
changed.
machines are a problem of uncertainty, because sometimes you put the money, you try to get a product, and you get nothing.
Yeah.
Sometimes you get 2 of them. So by repeating it, enough times, eventually you will get 1 product per coin. That's.
So what about Risico? A game of Risico?
It's called risk.
Maybe it is
You
strong.
want big board.
Yeah.
soldiers.
It's literally called Risk in English. Yeah, that's a good point. Yeah.
Yes.
I mean, unsurprisingly, there is an element of risk in Risk, the game. Risico is in Italian, okay? But there's a board. There's some countries you can move. You can move your armies into one country and the other to try to conquer it. What is the element of risk in Risk? Pardon the pun.
You have to choose
Dice.
The dice, exactly. In the moment in which I roll dice against you, this is set probabilities. Either I win or you win. There's no way we can alter this. This is set. This is purely risky. I mean, but Risico or risk, I would say is not purely, okay, this was a terrible example. It's not purely a matter of risk, right? There are also other components. What are the other components?
You can cheat.
What?
You can cheat.
You can cheat. You can interact with the other player. So this would go to a strong ambiguity.
Yeah.
There's one more part in Risico, in Risk.
Alliance.
Alliances, these are still in the strong ambiguity framework, right? Cards. You have the combination of cards. Those are an element of risk, but I guess you could also see as an element of uncertainty, because you know the deck has a set number of cards, you know your own cards, so you can assume that the cards you have in your hands are not in the hands of your opponent. Therefore, for you, that is a matter of uncertainty, right? Unless you cheat. Okay, somebody brought this up, it's fair. Proposing
Yeah.
to like a lady?
Yeah, of course.
That is a matter of what in your idea?
But
A matter of what?
uncertainty.
Uncertainty, because
Yeah.
she might say yes,
Or
she
no.
might say no. She probably already has her mind set.
Yeah. Or she needs.
You can try to probe her to see if she's more likely to say yes or no, so that you can avoid the risk. What, sorry?
You can't bribe.
You can try to bribe her, of course. That's a nice ring always works good as a bribe. But you are saying one way of seeing this is as a problem of uncertainty, because she has her mind set on what is her probability of saying yes or no. I just have no idea how big the leeway is.
Yeah.
So by dating, by still interacting, I can reduce this leeway. Okay, that's good.
Break.
Okay, so let's do like this. We take a small break of 10 minutes. When we reconvene, we try to see problems which are a matter of one type of environment from one point of view, and a matter of another type of environment from the other point of view. Okay, and we try to see how we can move across environment, and finally we give a definition of innovation and entrepreneurship, as Matteo used to do it. So yeah, small break.
10 minutes.
10 minutes. So 15, 20, we resume. Okay. Some examples in which the same situation belongs to two different categories of these, depending from the point of view. So we take a common situation and we see how this is risky for one perspective and uncertain from the other, and vice versa. Or, certain for one and uncertain for the other, any combination. Then we want to take some time to explore situations in which we can in some way modify the environment to force one environment to collapse into another. So we might take a certain situation, shuffle it up and make it ambiguous, or we can take an ambiguous situation, constrain it into uncertainty or whatever. Then a bit to give a definition, actually I think we can do this before, to give a definition of innovation and entrepreneurship under these light. We'll do this right now, I think it's better. Finally, we give you 2 or 3 things to bring in your pocket at home so that you go out of here saying, okay, today we did this. This is something which we can apply directly. I'm forced to say it again, please turn off your computers if you have them open, out of respect for the others which have turned off their computers and those who are speaking. Thank you.
Okay.
I don't want to be a bad cop, but computers, please. Thank you. Okay, good. Okay, so let's start.
Definition.
Let's start from a definition.
So, applying the 4 categories to the definition of innovation and entrepreneurship, we can define that in a certain and risky environment, so an innovation is about predictive probabilities for new optimal solution according to the risk factor, and we have a risk factor. And so the innovator and the entrepreneur is a person that inquires reality and takes a risk to develop it. So we want to have a better strategy to win at the classic roulette. And the entrepreneur is the one that can win a better strategy that maximize the winning and minimize the losses, according to the rule and to the risk factor. If we are in an uncertain environment, now the innovation becomes about acquiring information through routines to produce a satisfactory solution at the minimum cost. An entrepreneur is a person that set up an organization as an efficient and effective information processing entity. This is what we also briefly saw when we were talking about organizations. So organizations are entity that helps to acquire information, processing it, create knowledge to have a better outcome with the minimum cost. And it's why you need an organization. It's because you need to face an uncertain environment. Or you saw the environment as uncertain and you set up an organization that helps you to make it more clear and acquire information. So you start running routines and you start processing your information that you acquire through your routines. In an ambiguous environment, instead, the innovation is inventing plausible realities and convince others through means. So it's about inventing something that wasn't there before, to change it and convince the others that these things is real and these things is something that they need. And so the entrepreneur is a person that thinks about a plausible reality and sets it as true, creating a world in which this is true. So is someone that brings up new things and make them true. This is basically the idea of an entrepreneur in an ambiguous environment. Then we can discuss about some examples of all of these definitions. And you can think also of some more examples related to the actual companies or products that can be put in there. If you want to stick it to more a concrete innovation and entrepreneurship case.
Okay, so to give you the definition which our professor Matteo Bonifacio used to give about what is innovation, I personally, when I first heard it, I was like, well, that's nothing special. But then I started to understand what he meant with it. He used to say that innovation is the ability to change the truth value of a statement. So to change something which was false into true, something which was true into false, something which was partially true into totally true, and so on. So it's the ability to change the truth value of a statement. And the entrepreneur is the person that is able to carry this out. So who is able, as Andrea just said, create this plausible reality and convince the rest of the world that's how things work. Okay. So this was one definition. This is by no means the definition. It is one. It is one which kind of helps in guiding the discussion. And now we get into why it works like this. So I want to start with one category of examples. Those that, taking the same situation, have different angles with respect to how each actor sees the environment. I want to start from this one, which is actually one which came up last week to me. Does anybody here play Dungeons and Dragons?
I think.
Cool. There's a few. Does anybody here not know what Dungeons and Dragons is? Okay, a few. Oh, okay, that's a significant number. Okay, so Dungeons and Dragons is a role-playing game. Basically, this means we sit around a table, each person plays a character, which can be whatever, typically in a high fantasy setting, think Tolkien, Lord of the Rings, or whatnot. And each character is defined by how the person plays it, but also by a bunch of stats, which are numbers which you add or modify rolling of dice, okay? So I roll a die, I modify this number by some stat which is given on this character sheet, which is a sheet of paper detailing some statistics, and this tells me whether I am able or not to perform certain actions. Is this clear enough? Baseline, okay, roughly, okay. So one typical situation is the following. This is a high fantasy setting, so of course it's about epic stories and battles and whatnot. So the typical setting is where one character at the table wants to attack a monster. The monster is typically managed by one player at the table who takes the role of being called the game master, and he runs the session. So he tells the story and he tells the scenario which the players face. So this game master controls a monster and he knows all the statistics of this monster. The player, on the other hand, knows his own statistics and wants to roll to hit this monster. The way this works is that he rolls a die, which is typically a 20-sided die. Okay, so the result is ranging 1 to 20. He adds some number which he has on his sheet of paper. Then he tells the game master, okay, I did 22. Is this enough to hit the monster or not? The game master, without revealing it, checks on another sheet of paper what the threshold is, and if the attack exceeded the threshold, it hits, otherwise it doesn't. Okay? Example. You have +1 on your roll. I have 15 difficulty of being hit. You roll 15, you hit. You roll 14, you don't. You roll 20, you hit. You roll 10, you don't. Okay? Fair enough? Clear for everybody? Somebody who is not clear on this? Cool. So, from the point of view of the game master, so the one that knows your attack roll, knows your die, he knows your bonus and everything, and he also knows the difficulty of the action. What kind of situation is this? Risk. Why?
Because it depends on the result. If you involve the threshold that you set.
Okay. So in some way, it only depends on how the die will roll and what number will come out, right? This is a probability. If the threshold is 15, well, let's say if the threshold is 11 and you just take the roll of the die, so plus 0, no modifications. The threshold is 18, half of the times the roll will pass, half of the times it will not. From the game master's perspective, this is a purely risky situation. The player is rolling a die. Depending on the result of a die, the attack will go and hit or it will not. How is this situation from the perspective of the player? Uncertain. Why?
Because it knows only in a specific. Wait, the master can change the parameters.
That's a good point. For now, so the question is, can the game master change the parameter of the threshold? For now, let's say he doesn't.
Okay, that's uncertainty.
So it's uncertainty. Why?
Because you don't know all the parameters that the master has. You know only yours, so you can forecast if according to the value that you will get from the dice, you can hit or not.
Mm-hmm. So you can hit or not, so you don't have all the information, you can hit or not depending on the value of the die. But what I'm asking is, where is the uncertain element? Because we said uncertainty is in some way where you can repeat.
The threshold for hitting the master or not.
Okay, so you do not know the threshold,
Yeah.
but by repeating, what do you get?
The threshold.
You get an estimation of the threshold. You don't get the threshold itself. So you're saying, okay, I roll, 10, does it hit? No. Okay, I roll again, 20, does it hit? Yes. Okay, so you know it's between 10 and 20. You roll 14, does it hit? No. Okay, no, now you know that it's between 14 and 20, and you keep refining this till eventually you get the threshold, or the monster dies before, I guess, so there's no point in finding the threshold. Now, that problem which was originally of uncertainty for the player becomes a problem of risk, if he gets the tilting point. Because if he sees that 11 hits, 10 doesn't, that's the threshold. You have the cutoff right there, right? So the same situation was viewed as two different environments between the two actors. The player saw this as an uncertain environment. The game master saw this as a risky environment. If the game master cheats, because he's a bastard, and trust me, if you play any of role-playing games, the game master is a bastard and he does cheat, this will change. The problem might not even be risky. If the game master, for the sake of telling a more compelling and convincing and plausible story, decides that you will not be able to hit, regardless of whatever you roll, you are still thinking that you are in uncertainty. So you are still thinking, now I'm rolling a die, if I get a good result, I'm going to hit. But actually, you are in a situation which, from the game master perspective, is totally certain. You are not hitting that guy, or vice versa, you are definitely hitting it. So the same situation, changing the perspective, can represent a different type of environment. Do you have any other similar situations, games, TV shows, real life, classes, anything which have this kind of behavior? Same situation, you change the perspective, the environment changes.
Metrics.
Battles.
Metrics.
Metrics. What do you mean?
The movie.
Matrix. Okay. Why?
The perspective.
Okay, let's take a step back. Does anybody here not know about the movie The Matrix? Okay, everybody does. So can you elaborate, please, a bit?
Okay, depends on the point of view.
Depends on the point of view.
If you are inside Matrix or outside.
Okay, if you are inside the matrix, you see one type of environment.
Yeah.
And for example, what kind of assumptions in these categories can you make about the environment?
So, ambiguity.
Okay, you can say it's ambiguous.
If you are outside, you are in a certainty environment.
Okay, you can say, well, if the
Because this is
matrix,
the truth.
yeah, if the matrix is a simulation and it is fake, if I am living in the matrix, and I'm taking that here everybody knows how it is, I'm perceiving the simulation in which I'm living as if it were real and therefore as if it were ambiguous. However, if you are outside the matrix, you know that is a simulation, you know it is run by machines, therefore that is certain, it is deterministic, it has no ambiguity, because it's preset, and you know the truth. The truth is that is a simulation, that is false, for example, or that is true, that there is a simulation. While if you are inside the matrix, you do not know how the environment is around you, and you do not even know if you are in a simulation at all. That is totally ambiguous. Okay, that's a good one.
Other example?
A gift we received from the point of the person who receives it is not. It's very, in some points, very. It has some ambiguities, but from the point of the person who bought it and is handing it out, is certain that what's inside.
Okay, so if I'm gifting you a packet, I definitely know what is inside of it, so that is a certain gift for me. However, the person receiving it will see it as something which is definitely not certain unless he knows in advance what it is.
Yeah.
So this means that he will have a range of options, and I don't know, maybe he knows that you had like 3 options in which you were choosing, and in this situation for the receiving person, that's a risk situation. If it is something which he does just knows that you might have an idea about getting that is uncertain, otherwise it's totally ambiguous. So a gift is certain from one perspective and not certain from the other. Okay, that's a good one.
Compiling a program.
Compiling a program. How so?
Because
Look, this is very fair. This is very fair.
Because to the point of view of the machine compiling, the process is clear. It either compiles or fails to compile, because it does a mechanism that either goes on or fails, but it's certain what it will do. For you,
And you do not know until
you press the enter button. But from the point of view of the programmer, you don't know if it will compile, won't compile, why won't compile, and if you know what would be the matter, because maybe you think that the matter is in the code, maybe it's in the library, and you don't even know.
So why a piece of code compiles or not, from the point of view of the machine, this is totally certain. If there is a, I don't know, like syntactic mistake, it will not compile. However, you as the programmer might not have noticed it. Therefore, for you, that is not certain at all, while for the machine, it is. Also notice that, taking a similar example, if you think about runtime errors, these are even more tricky, right? We all know what a runtime error is, I'm assuming. A runtime error is deterministically, has some probability of happening or not happening from the point of view of the machine. From the point of view of the user, you might never encounter it in practice. So you might have a perception that something is certain, something is risky, but you do not know how it is. The machine, however, if you were to like be in the machine, would know it. So runtime error is a yet different matter, right? Others, please.
Yeah, I mean, we don't know we as students of the innovation and entrepreneurship course don't know who of the teachers would be there. Be the teacher.
Okay, yeah, that's a good point.
But so for us it's a risk or uncertain, and for you it's certain.
Okay, yeah. Who will be teaching the class is a matter of uncertainty for you as students, because you do not know who is actually going to be there until you come to the class and you see my face or Milena's face. We, as the teaching team, know this for certain. We know that we have scheduled that tomorrow I will be here or tomorrow I will not be here, and we know in advance. So for us, this is a matter of certainty. For you, it's a matter of risk. So there's one probability out of 4 that one particular person is there or is not there. That's fair enough. Sorry? Sorry, I could not hear you.
Okay.
Yeah, that's fair enough. The development of a story from the point of view of the writer versus the point of view of the reader or the spectator or whatnot. What happens in the story is already set in stone from the point of view of the writer that knows the script. From the point of view of the reader, this might still be totally open to discussion. Okay, good. Another example which comes to my mind is marks on an exam. How do you see this working?
Not passing or 18 to failing.
Yeah, okay, so how do you see this working in practice? What kind of environment is, how it is different from the perspective of the teacher and the students?
Actually, to be honest, we consider innovation marks very ambitious.
Fair enough. That's very fair. That's very fair.
We do not have any idea how the evaluation works.
Look, this is absolutely the point. I'm giving you one more perspective. I've been in a situation myself in which I've done many technical courses, and I can guarantee that the evaluation criteria were not clear at all. Even in very technical exams. You might, because you don't know what the pass threshold is. The teacher might not even know what the pass threshold is himself. In some way, he might want to be convinced by your performance in an oral exam whether you are sufficient or not. Then he might be taken out of, kindness, say, okay, if I fail this guy, he will lose his scholarship. So I'm going to pass him with the bare minimum, even if he is not sufficient. So this is a matter of either strong ambiguity or it has different perspectives according to the just going a bit further. The students. How do you see this, or how can you think of a exam which is risky? Which is a risk exam? Anybody really?
A written technical exam.
A written technical
there
exam.
There are some exams that you have the points for each exercise has a fixed number of points. Either you get it correct or it's wrong, and you get the points or you don't.
Yeah.
And
so if in the most trivial example, if it is a checkbox answer, that is purely risky. I might try to shoot it and put whatever. That's risky. I'm taking a risk. I might be wrong. I might be right. Depending on my luck, I can get it or not. This is purely risky. Uncertain. We kind of have seen how this works. So I might have a bracket. As a teacher, when I'm probing a student, I'm in a situation of uncertainty most of the time. I want to probe a student's knowledge. Let's assume in some way I can narrow it with some accuracy to a mark. Spoilers, it isn't. But the assumption is that as the teacher, if I keep probing the student, I can refine my judgment about his knowledge until eventually I narrow it down to his mark, to his level of knowledge, which I judge to be 10 or 8 or 7 out of 10, of course. This is an issue of uncertainty.
Also, Oracle machine.
Oracle machines, okay, go a bit into this, I like it.
It is certain for the Oracle machine if a grammar is ambiguous or not.
Okay, can I suggest this? The example is nice, but don't overload the syntax. As in, now ambiguous has 2 meanings, okay? So if I can suggest, the Oracle machine example is interesting. If you move it to somewhere which does not contain the word ambiguous.
I'm trying to rephrase actually.
The problem of undecidability is what I was thinking.
So it's better.
The problem of undecidability. Is anybody here not familiar with the problem of undecidability? Or the halting problem? Okay, so I'm assuming everybody is familiar. If you take, so the halting problem states, well, very briefly, that some some programs might be undecidable as to whether they will hold some programs or they will continue on forever. Okay, there might be a situation for which I can, as a expert, let's say, intuitively say this is not going to hold. So from my perspective, this is a matter of certainty. From a perspective of the machine does not know. It's in a weakly ambiguous situation. He needs to run it until eventually maybe it will stop or not, or it might not even stop at all. Okay.
Let's make a more entrepreneurial example, which is the iPhone, for example.
Of which there is one here, by the way.
So, before the iPhone, how was the world for Nokia, for example? Certain.
You're selling a lot. So
No, Nokia,
yeah, from point of view, no, from Nokia.
before the iPhone.
It was the top
Okay,
seller.
So we can say that it was mostly certain. They were selling a lot of things.
Monopoly.
Not a monopoly,
Not a
but still-
monopoly, but, you know,
still.
they were in a good
They
position.
They were in a really certain position. And then the iPhone came up, and how the world become for the actually how was the world for Steve Jobs and Apple when they launched iPhone?
Okay, why?
Right?
Why ambiguous?
Mhm.
Because it was the only operating system was being managed by Nokia, Java, and Symbian,
Okay.
and iOS was totally something new. So he had, in my opinion, he had no opinion whether he would lose or guess this much market share. So it was, and because of the strength that Nokia had, well, that he could actually lead the market. So it can bring some ambiguities.
So this was definitely an ambiguous situation in which neither, or actually from the point of view of Apple, they did not know how to move on. So this was a weakly ambiguous situation.
Yeah, yeah.
Okay, yeah.
And you need to cooperate to
Okay.
defeat competitors.
Okay. So in this way, this is a more strongly ambiguous
Yeah.
perspective.
And now how's the world for how's the environment for Nokia and Apple?
Okay, there's no environment.
There's no Nokia in the
Nokia
environment.
started again to do mobile
Yeah,
phones, so
But it's more uncertainty from my point of view. Because
Uh-huh.
he's making some Android phone, but it's not gaining
okay.
the same.
Okay. And how's the world for the environment for Apple now?
It's risky.
Yeah, it's risky.
It's not certain as it was for Nokia. Because Android companies, either Samsung, Huawei, or some Chinese manufacturers we do not even know the name, are just having their own share of the market.
Okay. But still they move from the ambiguity to
Yeah, up.
up. Okay. And that's is what an entrepreneur wants to do actually. So going from a ambiguous situation to a certain situation.
Or vice versa.
Or vice versa. Take a situation that is certain and make it ambiguous. So this is the idea of innovation and entrepreneurship. So to having an environment that is ambiguous and freeze it in a certain environment,
Yeah.
or ever a certain environment and unfreeze it and becoming more ambiguous. And let's make it more a plastic world where you can you shake it, and then you can, I don't know, like in the game for the baby, the kind of plastic that you can do some figures and then you cook and it freeze. So this is what you want to do if you want to innovate and you want to be an entrepreneur. That's it. So this is why we are talking about this worldview, because it can help to understand where you are. It can help you understand what's your situation, your perspective, but also to understand that there are others out there that have different perspective on the same issue, and maybe are competing with you or not, or maybe they didn't know about you or you didn't know about them. And so you need to understand what's your position within and how do you will act to change the things. So this is more or less the main point. Another example before finish could be diplomacy, for example. If you take an historical example, at the beginning of the First World War, Italy had an official treaty with Austria and Germany, officially. So for Austria and Germany, Italy was certain an allied, but actually Italy made a secret treaty with France and UK against Austria and Germany. So from the perspective of Italy, Austria and Germany wasn't allied, but enemies. So the world was more, let's say, ambiguous also for UK and France, because they weren't sure about Italy, if they will comply with the treaty or not, for example. So Italy remained 1 year neutral before entering the war with France and UK. So this kind of thing could be also related to diplomacy and secret things that you can do to change the world. So also to manipulate it.
Okay, so before going, just summarizing what you bring out of here in the pocket, okay, since I promised this. So we gave a definition of innovation and entrepreneurship, okay, which is one perspective of how we can approach this. You will see that basically everybody's going to have a different definition of this. And in this sense, you realize that this is not a certain definition. This is not a definition as we do it in mathematics. What is a function? Function is defined as column, that's it. There's no arguing about it. These definitions are more subtle, but they are something which are an asset for this course and for this track. You also bring home, hopefully, these 4 environments. They are not, if you notice, we haven't put anything prescriptive about them. So we haven't said, if you are in ambiguity, therefore you must act like this. This is not the point of the course. We want to give you some broad ideas, some thoughts, some possibilities of what these are. If you want to go on a more prescriptive side, there's plenty of literature, because of course, people like writing about this. Before we go, we just want to give one task for the next time. We will send you the paper which defines the methodological grounding for the battles. We ask you to please read it, at least go through it, and by the next class, which is not going to be next week, but the one afterwards. Okay, so next week is leap because there's graduations, and like the university has suspended all classes for those few days. So in the week afterwards, we will discuss a bit about the content of that paper. So please, you're asked to read it. This is kind of a mandatory reading, as in we might ask it in the exam questions, we might ask it in, we require that you know it, okay? Then we will also give you some other papers which outline these 4 environments. These are more optional readings for those that want to enjoy it or not. Okay, you're free to do it.
But so for tomorrow there's a battle?
Tomorrow there is a battle, 2 p.m. behind our backs, or in front of you, I guess, behind this wall. Okay?
Sorry, what about the preparation?
Hold on.
Tomorrow.
Just a second.
The preparation for the next battle.
Yeah.
Tomorrow.
Preparation for next battle is tomorrow after class.
Okay.
Any more questions?